Okay, now we're going to move away from graphing just a little bit and start talking about logarithmic functions. Remember that exponentials that are of the form y equals a to the x pass the horizontal line test. That means they have an inverse, and their inverse is a logarithmic function. So the relationship is what we're going to explore in this video between the two functions. And how do you move from one function that's logarithmic to an exponential and going the other way? This particular part right here, let me just grab a highlighter, is particularly important. And when we get to class, I'm going to show you a mnemonic device to help you remember that. But basically what's happening here is you have a base, which is A, on both of them. You have a number that is X, and you have an exponent, which is Y. And the A and the X and the Y are in both versions. So we can very easily transform one to the other and vice versa. So for example, if we had 2 equals log base 3 of 9, we can rewrite that in exponential form as 9 equals 3 squared. And I think this version, this exponential version, looks a lot more comfortable to you than the logarithmic version. Here's another one. 5 cubed equals 125 can be written in logarithmic form as log base 125. Log base 5 of 125 equals 3. So notice the interesting part here. In logarithmic form, this is always the exponent. That's just something to notice. When we're evaluating logarithms, we have to remember that the result of a logarithm is an exponent, like I just showed you. This means that log base a of x is the exponent that a is raised to obtain x. So here you have this 3 is your exponent. Because 2 to that power equals 8. So it's very, very important to remember that the result of a log is the exponent. That is the output. So here are some examples. If we do log base 2 of x, what does that equal? And they've done the solution for you here, but what I would say is 2 to the something and I would have to figure out what that value is. Now, using x is probably a bad idea in my case because they're using x in a different way. So sometimes it's just easier to put a question mark there. 2 to what power gives you 32? And that's 5. Same thing here in B. 3 to what power gives you 1? This is really saying log base 3 of 1 equals what? And log base 2 of 32 equals what exponent? And the only way we can solve the 3 to the question mark equals 1 is if the question mark is 0. Anything raised to the 0 power is 1. When we look at log base 4 of 2, and we rewrite that, 4 to what power gives me 2? Well, that power actually is a fraction. because it's the square root. And remember, we can write square roots as powers of 1/2. Here we have log base 10 of 1/100. So I'm going to say 10 to what power gives me 1/100? Well, I can rewrite 1/100 as 1/10 squared, which is equal to 10 to the -2 power. And that's where they're getting that from. Now, there are some properties that can kind of help us. We typically don't solve these in the calculator because we want to be able to do them quickly. When you have log base A of 1, that solution is always going to be 0 because anything raised to the 0 power is 1. When you have log base A of A, that solution is going to be 1 because A to the 1 is A. When you have log base A of A to the X, that's going to equal X. Because when I take this A and this X, those two X's are the same. And when I have log base A of X and log base A of Y, that means that the X's are equal to the Y. And this is really our true first introduction to inverse properties and one-to-one properties, where in the inverse property, the log and the exponent with the same base essentially cancel each other out because they are inverses. And where one-to-one property comes into play is if you have a log of a term equal to a log of a term, and those logs have the same bases, then you're essentially dropping the log from the equation like this. That's really what the one-to-one property is doing.